All right, 7.3 is about similar triangles. Before we just talked about similar figures. Previously, to show any two polygons are similar, you'd have to show that all the angles are, and hopefully you are thinking not similar, but the angles actually have to be congruent. And all the sides are proportional. Proportional. So there is a shortcut for proving, that triangles are similar. Just like there was for proving that they were congruent. You know, we had side, 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 angle, angle, side, all those. We also have that in similarity. The first one is angle, angle similarity. And remember, we couldn't have an angle, angle, angle theorem to prove that they're congruent, but angle, angle is enough to prove similarity. And again, when you are talking about similarity in these theorems, you can abbreviate this, but you need to have that similarity symbol. So you have to make sure that you have this similarity symbol. All right. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So determine if these are similar if true, write a similarity statement, which is like a congruency statement that we've done. So if true, write a similarity statement. Let's see if I can get these to go up. Hold on. All right, well, I'm trying to get them to show up on my screen. They are in front of you, but not so much for me. All right, so if we know 42 and 58, again, we can see that two of these, there's two 42s on there, so those are congruent. The only way that I would know if they are congruent is I have to actually figure out what the other angle is that we need, because, you know, we have to add them to 180. So if I do that, 42 and 58 is 100. So this angle would actually be 80. So there you see that you have two 80-degree angles and two 42-degree angles. So these are similar triangles. And the similarity statement would be, for example, triangle ABC is similar. Oh, it's not, doesn't look like a similar symbol. Hold on. Is similar to triangle. And you should have the triangle symbol there. So we went from A to B and then to C. So we started at the no, we started here where there isn't an angle measure by the 42 and then by the 58. So we want to do the same thing on the other one. So I'm starting by the no, by the 42, and then to the 58. So it'd be FDE. So that is my similarity statement. How about these triangles? Are they congruent? Well, so far we have just angle, angle similarity that we have to look for, right? So we're looking for angle, angle similarity. I hope you all recognize that we have those vertical angles. So that's one set of angles that are congruent. You also see we have two sets of a set of parallel lines. Remember, alternate interior angles we look for. And so we have alternate interior angles that are congruent, and then also we'd have those other ones, because by third angle theorem, we know if we have two angles in a triangle that are congruent to two angles in another triangle, the third angles are congruent. But anyway, we do have angle-angle similarity. If we said, let's see, QXP, triangle QXP. So here we started at the 2, went to the 1, went to the unmarked, started the 2, go to the 1, go to the unmarked, be triangle NXM. And then here, given RS and UT are parallel, which it shows there, and everything else is as it's marked. Does it have, let's see, yes. Find our Q. Let me see if I can get these to go up a little bit for me. Give me a second. All right. Find our Q and QT. So again, we have the vertical angles that are congruent. I have alternate interior angles that are congruent. So I have to set similar sides over similar sides. I know 10 over 4. So I started with triangle 1, and I'm going to triangle 2. 10 over 4 equals 2x plus 10 over, and in the other triangle, the one that goes from a 2 to a 1 would be this one, x plus 3. And again, we have cross products that should be congruent. So I will take all of the 10 times that x plus 3 and set it equal to that 4 times 2x plus 10. If I distribute 10x plus 30 equals 8x plus 40. Subtract 8x, I get 2x. Subtract the 30, I get equals 10. So x is 5. Let's try plugging it in. This would be 20. 2 times 5 is 10 plus 10. This is 8. Now let's try our proportions. So let's go back. Little triangle over big triangle should equal little triangle over big triangle. Well, you see that it's just a scale factor of 2 or 1 to 2. So we definitely figured that out right. So x is 5, and we figured out our q is 8 and qt is 20. All right, here's where I feel like it comes in useful. We can use scale factor, or we can use, proportions to actually measure things functionally. So if we can't really measure a building because we can't hold a tape measure up to it, it's too big, we can't get to the top of the building, we can estimate it pretty well by doing something with the shadows. So Josh wants to measure the height of the Willis Tower in Chicago. So there's my X. He used a 12-foot light pole and measured its shadow at 1 o'clock. And he also measured the shadow of the building and saw the building's shadow was 242 at the same time that the light pole's shadow was 2 feet. And these are all in feet, so we're good with the same measurements. What's the height of the Willis Tower? So I'm just going to set up a proportion, 2 feet. So the shadow of the light pole over the shadow, similar things together, equals, I'm going to go back to the light pole because I started with the light pole, the height of the light pole over the height of the tower. So we get 2x equals 242 times 12, helps if you turn on your calculator, 2,904, or the Willis Tower is 1,452 feet tall. So another way we could have done it, we can set up proportions again, like I said, in a lot of different ways. So don't think that my way is the only way. That's the way that makes the most sense to me. I'm setting similar parts over similar parts. But we could have done shadow over height equals shadow over height. Now look at when you cross multiply, I have the 2 times the x. Well, here I had 2 times the x. The 12 times the 242. Well, here I had the 12 times 242. So it doesn't really matter as long as you follow the same pattern every time that you do a proportion. And that is it for angle. Now starting 7.4 in our book, we talk about side similarity and side similarity. And go ahead and read those over if you want to understand their definitions. We're just going to start using them. Determine whether the triangles are similar, so write a similarity statement, explain your reasoning, blah, blah, blah. Well, again, I know that those angles are congruent, but so we want to either probably be able to use side or side angle side. actually give us all three sides, so let's try with the sides and see what we come up with. Hold on. If we go with the sides, I have to find, I'm going to put the smallest side over the smallest side of the other triangle. Is that equal to the medium side over the medium side? And is that equal to the longest side over the longest side? And so what we do is we just plug those in. You could do cross products again, or I can just reduce my fractions. If I do, I get 1.5 for 6 divided by 4. If I do 7.5 divided by 5, it also is 1.5. Do we do 9 divided by 6? Hey, look at that. It's also 1.5. Since these are all the same, I know that these two are similar, and if so, write a similarity statement. The reason I would be using side similarity. If we wanted to write a similarity statement, again, I'm going to just start with ABC. So A to B to C, I went past the long and then the medium. So I want to go past the long and then the medium. So is similar to triangle DEC. All right. Here we have another set, and we have to look at the proportions again. Smallest side here is 6.6. Is 6.6 over smallest one here is the 5.5. Is that equal to medium triangle over medium triangle? And let's just try that one. So 6.6 divided by 5.5. This is 1.2. If I do 8.2 divided by 7.1, I get 1.15. So these are not similar triangles because the sides are not proportional. Determine whether DEF with vertices blah 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 is similar to LMN with vertices blah blah blah. First graph the triangles. All right, well here we go. Let's give it a try. Graph search. All right. So if we were going to graph these two, let me make it a little bit smaller. All right, negative 4, 0. 1, 2, 3, 4, 0. 6, 1, negative 1. 1, 2, 3, 4, 5, 6, negative 1. And 3, 3. So this triangle. And then we have the one that starts with negative 3, negative 5. Which is there. Secondly, 15. Well, look at that. So of course my thing only goes 10. So let me do the 11, negative 1. So 11 over negative 1 is going to be right here, let's say. And, but I can still figure out the lengths without having it, I guess. Let's do it on the one that the blue triangle, which is easier. So to find this length, remember I just used Pythagorean theorem. So I have a rise of 1, 2, 3, 4, and a run of, I can't even tell from my graphing, 3. Anyway, I'm gonna let you guys try this. It's too hard without a real whiteboard where I can write. I'm trying to do it on my laptop. what you would do is you find the length of the sides by doing Pythagorean theorem to find the hypotenuse. Once you draw in the height, the rise and the run, and then check to see if they're proportionate. All right. Corresponding parts of similar triangles is what we're going to talk about now. Triangle, if the triangles are similar, then all of their corresponding parts will be similar. All the angles are going to be congruent actually, but all of the sides will be proportional. And you can write up extended proportions. That's what this is called right here, extended proportions, where you're just saying all the proportions that are equal to each other. Determine whether the triangles are similar, so write a similarity statement, explain your reasoning. So if I look at this, I have this triangle in red, and then I have this triangle in blue, which is the bigger one. And as we sit now, are those, so we have to look at, do we have side, angle, side is looks like what we're going for. We can't go for side, side, side because they didn't give us a third side. We only have one angle because I don't know if those lines are parallel. But I can look, I have a 10 on my small triangle over this 10 plus 15, so over 25. And is that equal to 12 on the little triangle over its side, 12 plus 18, 30. So does 10 divided by 25 equal 12 divided by 30? And it does. They're both, you can either do cross product, meaning 30 times 10 is that equal to 25 times 12, or you can just reduce the fractions, and they both reduce to be 2/5. So, and I would say by side angle, side similarity, that the triangles are similar. So the similarity statement will be triangle MNP is similar to triangle NRS. All right, for the next one, we have the 57. But if you look here, side, angle, I don't have this side. Here I have a side, an angle, and a side. But on the other one, I'm missing it. Even though the 57 is the right, are both congruent, it's not in the right spot or in the same spot in both of those triangles, so I can't do that one. All right, that's just another one using shadows, and it's the same as what we've already done. You just have to figure out what this length is by doing 360 minus 18, and then we're trying to find the height of the building, and it's very similar to the one we've already done. And that is it for 7.3 and 7.4.